Okay, should be recording. Here we go. Stop recording. Okay, that looks fine to me. Don't want to pull up my mail here, but all right. I think we're going here pretty well. How's it going, guys? Nick here. I do tech and coding stuff. Say this in every video. Just check the description. You can see everything I do. But right now we're doing a what are we doing? LeetCode problems. God, we're doing LeetCode problem right in front of my face. And we're doing trees right now. Like I say, there's only about 40 problems on LeetCode. You could pretty much master tree algorithms if you do them all. So I would suggest that. Right now we're doing a preorder traversal. There's a few types of main traversals that we can do on trees. And we're doing preorder, postorder, and in-order. And I didn't show this in my last video, but if you want to just check this out, there's the, you can't really trust Wikipedia, but in this case they're right. I've looked it up on something else, but they just have all the information here, so I'm pulling this up. Preorder, postorder, and in-order really just refer to the way that the tree is traversed when we go to left subtree, right subtree, and root, right? So it's basically just the way that the root is traversed. So in preorder, the root is traversed and then the left subtree and then the right subtree, right? So when we see the output, F, root is outputted first, and then we got the left side, then we got the right side. In order would be left, then root, then right. Post order would be left, then right, then root. So root is outputted first, traverse first here, middle here, and last here. All right, that's pretty much just a rundown of it. And we're going to be doing the preorder traversal that's implemented right here. We're going to be doing it iteratively in Java. All right, so if you watch my other video, it's kind of the exact same method almost, a little bit different though. So we're going to have a stack. It's going to be a linked list called stack is equal to new linked list. Right, it's a linked list can be implemented as a stack if you use the poll last method, which is what we're going to be using. Poll last just grabs the end of the linked list, and that's basically the top of the stack. All right, so we have linked list node stack, and then we're going to have a linked list of integer, which is going to be our output array, right? And this is just going to be this array that we output, right? That's all it really is. Not too tough. And then we're going to do, this is in every algorithm problem pretty much. You're going to have to check if something's equal to null, whether it be the length of the list is equal to 0, so you just return an empty array. In this case, we're just checking if the root, because the root would be 1 in this case, and then it would have a bunch of children nodes. We're going to check if the root is null, because if the root is null, we have no tree, right? And we're just going to return an empty array, which is our initialized output array up here. So we'll just return output array. Next thing we're going to want to do is just add our root to the stack, because we know it has some kind of value and it exists. And then we're going to loop through the stack, right? And the stack is literally just going to have our root at first. So while stack.isEmpty, stack.isEmpty is going to check if our stack has anything in it. If our stack has anything in it, stack.isEmpty. We're going to do not empty. We're going to make sure it's not empty, right? And then we're going to pull the top of the stack. The top of the stack is going to be, stack.pull last, because it's actually a linked list. But pull last, like I said earlier, is going to be the top of the stack. Then we're going to do output array dot add. In the post order traversal, you do add first, but in this we do add. So we add to the end of the array. It's going to append it to the array, right? We're going to add node.value, which is going to be that integer. That's why we have an integer array, right? This is the only different part here. We're going to have to do collections.reverse node.children, right? So when we get these node children 3, 2, 1, we would reverse it and it would be 4, 2, 3. And then we're going to add them to the array, and that's how we actually get the preorder traversal. Maybe I'll explain that a little more in a second. And then we're going to loop through the children here for child in node.children, and these are the reverse children. We just add them to the stack. God, I always have trouble with these brackets. Sorry. Stack.add child, right? And then we just return the output array. Hopefully this works. I should have done the run code so that you guys could see that it works, but sorry about that. There we go. Success. That's all the test cases, and then I'll do the first test case just so you could see the output just how we want it. So it works 13%. Once again, I always say this: LeetCodes don't get discouraged by the percentage of people that you beat, because LeetCode changes it every time. Because things like internet connection and stuff like that. So it just went from 13 to 8. That's pretty strange, but maybe it's because a bunch of other people submitted since it's 1 second ago. But I think it has to do maybe with Wi-Fi a little bit. I'm not 100% because sometimes I see it at 10% and then it jumps to 90%. So very interesting to me. So let me just go through this again. We have a stack. We have an output array. If the root's null, you return nothing. Otherwise, you add the root. Then while the stack's not empty, we pull the last element of the stack. We pull the top of the stack, add it to the output array, add it to the front of the output array. So in this case, root would be 1. Add it to the stack. While stack's not empty, we pull 1, add it right there. We add it right to the end of the array, which is nothing. So it's just going to be an array of 1. Then we reverse the nodes. So we have 3, 2, 4, but it would be 4, 2, 3. We loop through 4, 2, 3. We add them to the stack. 3 would be pulled off the top of the stack next because it would be 4, 2, 3. So 3 is going to be the last element in the array, top of the stack. Pull 3 off, add it to the output array. So now it's 1, 3. And, we repeat the same process as we go along. There, and that's pretty much it. That's the pre-order traversal there, and we're going to be doing in-order traversal next. So check out these tree traversals. Check out any other problems. Let me know in the comments if I'm doing okay at explaining these. I'm trying to get better as I go here, and also tell me if I do anything wrong in the algorithms or if I'm explaining it wrong. But hopefully I'm doing it right. So thank you guys for watching. Really appreciate it. And I'll see you guys in the next problem. See ya.